Quantitative Analysis Essentials. Your complete study guide. Quantitative data analysis. Analysis data that is number-based. The process of converting data into numerical form for systematic examination and statistical interpretation. Example: female equals 1, male equals 2. Quantitative applications. To measure differences between groups. To assess relationship between variables. To test hypotheses scientifically. Quantitative applications. Two main branches. Descriptive statistic. Inferential statistic. Quantitative applications. Descriptive statistics. Deals with summarizing and describing data using measures such as mean, median, mode, and standard deviation. It focuses on organizing, presenting, and analyzing data to understand its basic characteristics. Inferential statistics. Involves making predictions or inferences about a population based on a sample of data. It includes hypothesis testing, confidence intervals, and regression analysis to draw conclusions about relationships or differences within data sets. Quantitative applications. Population vs. sample. Quantitative applications. Population equals the entire group you interested in. Sample equals the portion of the group that you can actually access. Quantitative applications. Descriptive statistics. Focus on describing the contents of the sample. Inferential statistics. Aims to make predictions about the populations. Descriptive statistics. Focus on describing the contents of the sample. Inferential statistics. Aims to make predictions about the populations. Typical most common descriptive statistics. Mean, average. Median, midpoint. Mode, most common. Standard deviation. Skewness. Why descriptive statistics important? Descriptive statistics offer both a macro and micro view of the data. They help detect errors and anomalies in the dataset. Descriptive statistics guide the selection of appropriate inferential statistical tests for further analysis. Typical inferential statistics. Aim to make predictions about the population. Two common uses of predictions. Predictions about differences between two or more groups. E.g., income differences between a group of professionals. Predictions about relationship between two or more variables. E.g., link between study hours and exam scores. Tips: sampling problem. Population: 60% of students prefer tea, 40% prefer coffee. Sample: in a survey, 80% of students prefer tea, and only 20% prefer coffee. This discrepancy between the population and sample preferences indicates a potential sampling problem. Inferential statistics. T-tests. To access differences between groups in terms of mean, standard deviations, skewness. Let's say you're comparing the exam scores of two groups of students, one group that attended extra tutoring sessions, Group A, and another group that did not, Group B. By conducting a t-test, you can determine if there's a statistically significant difference in their mean exam scores, helping you evaluate the effectiveness of the tutoring sessions. Inferential statistics. ANOVA. To access differences between multiple groups. Let's consider an example where you are comparing the average scores of students in 3 different teaching methods: traditional lectures, online courses, and interactive workshops. By using ANOVA, analysis of variance, you can determine if there's a statistically significant difference in the mean scores among these 3 teaching methods. This helps assess which teaching method is most effective in terms of student performance. Inferential statistics correlation. To assess the relationship between variables. If variables A goes up, does variable B go up or down? Let's consider an example of the relationship between study hours and exam scores. If there is a positive correlation between study hours and exam scores, it means that as the number of study hours increases, the exam scores also tend to increase. Conversely, if there is a negative correlation, it means that as study hours increase, exam scores tend to decrease. Inferential statistics. Regression analysis. To assess the causal relationship between variables. Does variables A's movement cause variables B's movement? In a study on employee productivity, we use regression analysis to examine the causal relationship between training hours, variable A, and sales performance, variable B, among sales representatives. The analysis helps us determine if increasing training hours causes an improvement in sales performance, indicating a causal relationship between the two variables. How to choose the right quantitative methods for my study. 2 factors to consider. Types of quantitative data you have, data type and shape. Data type, nominal, ordinal, interval and ratio. Different methods require different types of data. Research questions and hypotheses. How to choose the right quantitative methods for my study. Choosing the appropriate quantitative methods for your study involves considering 2 key factors. Firstly, assess the types of quantitative data you have, which can include nominal, ordinal, interval, or ratio data. Different methods are suitable for different data types and shapes. Secondly, align your choice of methods with your research questions and hypotheses. For instance, if your study aims to analyze the mean and median in a group of people, descriptive analysis would be the suitable method. By matching your data type and research objectives, you can ensure the accuracy and relevance of your quantitative analysis. Thank you for watching. Happy study, never give up.